I'm Tim Reece of All Printing Resources. I work for our technical services group, and today the focus of this demonstration is going to be on QEA's second generation of the Flexo IAS. IAS stands for Image Analysis System. This particular device, the way it differs from the original device is this is now tethered by USB. The original device actually had a small computer on board, also a handheld device. The advantage to this is it does connect to your laptop, your PC, and the speed of the processing is just greatly enhanced. This particular device, the Flexo IAS II, it will measure the black mask of a digital plate. It'll measure a film negative. It'll also measure the plate itself. It'll measure the print. So today, just in hopes of keeping this rather short, we're going to focus on a 067 digital plate. It's a solvent wash plate. This particular plate's 120 lines per inch, and we will start by measuring what's identified as the 1% patch, but likely we'll measure more about a 0.5% or a little bit closer to 1. There's three components that we'll be working with for this particular plate analysis. Those three components are the Flexo IAS II, a laptop or a PC, and then also the light box, which illuminates through the translucent plate. The way this differs from a standard light table is that this light box has a single LED inside. Over the LED is a lens which collimates the light and allows the light to pass straight through the plate. When we then look at the plate on the screen of the PC, any flat area of the plate, whether it's face or floor, will show up as a white light. Any non-flat area, such as the shoulder, will show up as either black or a shade of gray. We're going to start with a 1% highlight dot. We place the plate over the light box and then the device on top of the plate. We take a measurement, and this measurement is actually going to come up incorrect. What I'm looking to demonstrate at this point is some devices will measure anything that shows up as white on your screen. This device will do the same thing, but you can see we're actually picking up on areas in between actual dots. Everything that this device is reading right now is highlighted in red. What QEA has done to make sure that it's reading a true dot versus flat areas in between the dots is they've given us a highlight dot icon, which then allows you to select two true dots that are side by side in these two small regions of interest, and then the device would know to go that far in every direction before looking for another dot. So we're going to hit our highlight dot icon, and you can see now that it's selected true dots, and the areas in between the dots are still white, meaning they're not being measured. To the right of the image area is our results panel. Focusing on the results panel, we see there are several areas of interest. We're just going to touch on a few of these. The very first area is count. The count in this case is 96. It means that all the data underneath each individual heading is based on 96 individual dots. That's what we call the mean. There's also a minimum column and a maximum column and a standard deviation for each one of these measurements. Going down, we see diameter. Now, most people really don't focus on diameter so much. They think about a dot percentage, but what's important about diameter is when you're measuring a tonal patch, all the diameters of these, in this case 96 dots, should be basically the same. As we can see, we have a minimum diameter and a maximum diameter and then a standard deviation. Going further down, we see measurements like box ratio. Box ratio is just telling us how much elongated or not elongated these dots are. It takes the height of each dot and it divides it by the width of each dot. If a dot were 10% higher than it was wide, we would have a measurement of 1.1. If it were 90% as high as it was wide, we'd have a measurement of 0.90. Circularity is the next measurement down. Perfect circularity is a 1.0. The way this device calculates circularity is that it's actually the perimeter squared divided by 4 pi times the area. Now really what's most important to remember about circularity is it's got an acceptable range of 0.9 to 1.1. Going further down, we have the ruling in lines per inch, lines per centimeter, and also lines per inch. The lines per centimeter in this case are 47.2, and the lines per inch is 119.8 or 120. It also gives the screen angle. Of course, that's relative to how you've placed the device. And then last but not least, and what most of us are focused on, is the dot percentage. And in this case, it's a 0.5, so it's a 0.5% dot. The next few measurements we'll take will be through the Midtone range. We've already laid the 067 plate over the light box, got the Flexo IAS into position, and we take our measurement. Again, everything that the device is measuring is highlighted in red. This would be our 25% dot. We'll move on to our next patch. And as we go through, we can actually create a data log and save all of these measurements. And finish with the 50%. Again, the fact that the device is highlighting each of the dot in red is a good indicator that you're measuring the correct area. Last but not least, we'll focus in on the shadow area. When the device is on an auto setting, it actually knows how to distinguish between the shadow area and the highlight area or the midtone area. So the polarity of the device actually changes from light when reading through the highlight dots and the midtones to dark for the shadow areas. And once again, we can see the areas that it's focusing in on are highlighted in red. Inside the red circle, you can see like a dark inner circle and then a white dot in the very, very center. What that white dot you're seeing in is it's actually the floor of the plate in this reversed washed out area. In this case, the machine's intelligent enough that it's doing the reverse math. It's actually reading the dark areas, but it's doing the reverse math, and it's coming up telling us that this area is a 82.8% dot area. And that will conclude the plate measurement portion of this device.